Hey guys, here is another feedback problem, problem 75 from the assignment, our assignment. In this case, you have given the capacitor plate or two plate, positive and negative plate, the electrical potential between those two plates 5,000 volt. So you can assume the upper electrical potential will be in the positive plate and 0 volt in the upper one, in the negative sign, which is the lower electric potential. And here you given the positive charge, but in the middle with the velocity, certain velocity, in this case VO, or we call it in our case VI, 3 power to the 5 meter per second. And basically, with the capacitors, as we mentioned before, it has electrical field point up. So that point up, you push the positive charge to the upper plate. And the upper plate, since the charge starting with the speed, so it's gonna be go with the path going to the upper plate. And it will hit the upper plate and somewhere here. And here is the final positions. And here we ask how much velocity the positive charge will hit upper plate. So here is the V final that we need to find. My initial positions right now, here is my initial positions where the positive charge start with. What regarding for my VI, initial voltage, in this case, since it is in the middle, it will be 2500 volt. So from that case, delta V basically minus 2500 volt. Now, basically we're gonna start it with the conservation of energy. EI equal E final. Where is the energy here? We have kinetic energy plus the potential energy. I just can rewrite my equations in that case equal Kf final kinetical energy, which my final velocity here, equal initial velocity or initial kinetic energy based on the initial velocity minus my delta potential energy. Where is my delta potential energy here? It just basically Q delta V. That's my electrical potential energy. Okay, so now we can find all those, we have it. So I can find my Kf. So the Kf I have here is the half. M, where is the M? Don't forget, guys, M for the electrons, 1.67 power to the minus 27 kilogram. That's my M. So here is the 1.67 power to the 27 kilogram, half M. V square, I have my V. It will be 3 power to the 5 meter per second. Here is the meter per second. This one is gonna be square. This is the Ki minus. I have here's the minus, so it's gonna be positive. Q 1.6 power to the minus 19 column times 2500 volt. So in this calculation 0 and this number is here, 4.75 power to the minus 16 joule. So we know that the final kinetical energy equal half mv final square. So from here, I can type my V final equal root square of 2 K final divided by m. I have all the informations. Here is the 2 times k. We found it is 4.75 power to the minus 16 joule divided by m 1.67 power to the minus 27 kilogram. And from that calculations, you end up with the velocity 7.5 power to the 5 meter per second. We expected to see or this charger will be speed up when it hit the upper plate with the speed 7.5 power to the 5 meter per second. I hope you find this video is useful, and the student who asked these questions now he able to get the right way to answer. Thank you so much.